Okay, good morning, Delgado folks. How you doing?
Good.
Good morning,
Oh,
Professor.
Good morning.
good, good.
Good
Good to
morning.
see you folks. All right, so just to show you what's going on, today in the 120, we're going to finish up that chapter. Tomorrow will be a review day and then test on the last day of the week, Thursday. So does anybody have any kind of questions about anything?
Well, I had to leave due to an emergency the last
Right,
class,
yeah.
so I'm kind of
I saw you.
backed up.
All right. So you
Well,
got anything specific that I can
I'm
help you
still
with? Like,
struggling. Oh, sorry.
is that you, Alicia? Because you sent me that
Yes.
link. Do you
Yeah.
have an example of an like the first place you ran into problems?
Um. The truth table. I think I finally got the concept of it. But creating the truth table, I don't know why I just get
All
tricked up.
right. Well, if you can give me the statement you need to create for it, you can type it in or screen share or whatever, or text it to me. You can send it in a text message on my
Okay,
phone.
let me pull
I
it up.
just want to be able to. I like to have an example because otherwise, if I go and get one, it may not be suited for what you're looking at. I mean, I know how to do the truth table, so I can pick anything, but I want to see which one you were working with if I can.
Okay. I'll send it to you. I don't want to hold up the class.
Well, that's all right. We're gonna. So, what about you, Matthew? Did you have something that you were?
Well, no, I had to miss both classes, so I'm kind of like way far behind the class. And if you could send me your text message, shit, your text, your phone number, that way I could go through all the past video recordings and see if I have any problems.
It's right there. See?
Oh, got it. Hold on, stay right there for a second. All right, got it. Thank you.
And then, of course, the recordings are here. So again, every time I cover something in class, after the 120 class, I post what we did in the O2 over the video, and then the one for that 120. All of these are ones that I did last semester. It may be
Okay,
slightly
so
different.
Mr. Cruz, I was working the
Mm-hmm.
one with the P to R, I mean the P, the Q, and the R. That one had me kind of like tripped up. So for the R, I know you do like for P, you do T T F F. So
Okay, give me the statement.
okay, it is I think it's the negotiation of P and Q.
So the negation of P.
Yeah. And Q, or the
All right, hold on a
negation of
second. Hold on a
P,
second.
the negation of P, or negate the negation of R. But
So is that it?
it's in parentheses. Let me see. Create a truth table for no. It's the negation of P and Q in parentheses.
So it's and.
Yeah, and Q.
So that
No,
is that it?
no. Put the Q by the and. It's the negation of P and Q. Then parentheses.
Okay. Oop. So that's it.
Yes. And then they have the R,
Or
which is the V. Yeah. then they have the parentheses, the negation of P, R, which is the V, and the negation of R in parentheses.
So is that it?
Yes.
So with this one,
Alright,
wouldn't you need some background?
What do you mean background?
Or can you just
Not to create.
create?
Yeah, to create a truth table, all you need is that symbolic statement. If you are working with it in verbal form, then you're going to have to convert it to this before you do it. But yeah, all we need now, we got in this shape. All we got to do is just create the truth table. So, how many statements are there, individual statements in here? P, Q, and R. How many is that? 3, right?
Yes, 3.
Yeah, 3.
All right. So then here, we'll put P. And if there's 3 statements, then there's going to be 8 rows. It
That's what I
follows
was
that
trying
same
to figure
pattern
out. I was like, oh, we have 8 rows. Okay.
because it's 2 to the 3rd power. That formula from chapter 2, where you talk about the number of subsets, it's the same thing.
Okay.
So every time you add another statement, it's going to double it. So if you just have a plain old 1 statement, it's going to be just 2 rows, 2 to the 1st power. If you got 2 statements, P and Q, let's say, then it's going to be 4. And then you got 3, it's going to double again. So the way that we set this up is we're going to write down half T's. So there's 4 of T's. And then we're going to do 4 F's. And it works a lot better on lined paper. I'm a sloppy drawer anyway, so once you take me out of freehand form, put me in freehand form, it gets terrible. So that's, see, half and half now. Now we're going to essentially go half again and half again, if that makes sense. In other words, we're going to do 2 truths.
Okay.
And then 2 falses all the way down. See that? Back to truths. 2 truths. 2 falses. And in the last column, whether you're doing 1 or 2 statements, it's always going to be just true, false all the way down.
Oh, so that's the algorithm.
That's why I was messing up there, because I didn't know what to put for the 3rd column, because I knew what to do for the 2, but the 3rd had me confused.
So if you do that, it makes all of them unique. So you got 3 truths, true, false, true, false, true, false, false, true, false, T, true, false, true, and false, false. It's got all of them. And we'll talk a little bit more about that in chapter 10. That's what we call permutation, a permutation. Each one of those is ordered differently. All right. Now, what we're going to do is we're just going to go left to right, starting with the most complicated part. And with these, inside of the parentheses is where we start. And then we just go left to right. All right, so I'm going to put, so what we need is we need
Another column.
those negations. Those negations we need.
I think because it's so tedious, it makes it easy to get frustrated.
Yeah, it is. But like I said, you just go left to right, working inside in the most complicated part.
Mhm.
All right. So that's the first thing. That's this one right here. So we need to know what that is because it's really hard to do this in your head to do
Mhm.
because you got 1, 2, 3, 4 steps in there that you got to do before you can do anything else. You got to do those negations. Actually, there's only
Mhm.
3 because the P is twice. So now all that's going to be is just the opposite of this one right here.
Mhm.
All right. So what we're going to do is just do 4 falses now because the negation is just the opposite. So the opposite of true is false, true, opposite false, true, opposite false, true, opposite false. And then down here, the 4 T's. All right. Sorry it's so sloppy. I need to come up with something better to do this, but it takes a while finding good stuff. Now, in order to put these two together, we got to know what this one is. So we're going to put here the not Q because we're going to need that in order to figure out what that first one is, that first parentheses. So it's just going to be opposite of that middle column. So instead of true, true, false, false, true, true, false, false, it's going to be false, false, true, true.
Mhm.
Does that make sense? It's
Yeah,
just
I
like
just
whatever you do.
didn't know how to mark them.
Yeah, I mean, it takes a while. And I told you when I took this in college, I actually took it in a philosophy class. That was a part that got me hung up was how do you know which ones? Because I thought you were recreating them every time, but this part you're not. The 3 parts over here, those 3 columns, you're not recreating them. You're using them as they are standard. Because if you do that, then you'll match up with everybody else and answers and books and all that. All right. So now what we're going to do is we're going to put these both together. We're going to do this whole part on the left. And I'm just going to put those 2 together with what symbol? What do you see in between those 2?
That's the
See
or,
that?
right?
It's
That's
the
the
and.
and. You got to make sure we get it right because there's 2 different rules. So remember, I got that thing somewhere. Let's see if I can bring it up. Because that's one thing I told you to try to do is just use this as a somewhere in here. I got so many screenshots.
I do have one question regarding this.
What's that?
For the P's and Q's, the trues and false, with the homework, I noticed that there was like 4 of them. Like
Yeah,
4
you're
like
going to select the right one.
like how do you determine how many true false do you start with? You see what I'm saying? Because I see you have 4 trues, 4 false compared
Okay.
to the homework.
Let me get that. All right, over in chapter 2, remember we had that formula, a 2 to the n, 2 to the n, to tell us the number of subsets. So
Yes.
if there's just 1 in your set, it's 2 to the first power 2. If n is 2, if you got 2 elements, it doubles it to 4. If you got 3, it doubles it to 8. So that's what pattern this is taking.
I
You
see
won't
it
have
now.
any more than 8, but in theory, if you had a P, Q, R, and an S, then there would be 16.
And there's 4. I see it now. Thank you so much.
Okay. All right. So where did that thing go? All right. So this is that summary. And I've tried to impress upon you that we want to make sure, oh, there it is, that this is close by until we learn these things. All right. So the one we're doing now is this one. All right. We're using the and, see? So the rule for the and is, and I've got it summed right here. This is the way I like to do them rather than just memorize the 4 positions. The conjunction is only true when both of your columns are true. And you're only looking at them 2 at a time. So on this, that's 2 false. As long as we get an F, this is false. Doesn't matter how many T's unless you got 2 of them. These are all going to be false as long as they got 1 F in there. So these last 2 are the true ones. Okay. So that's that side. That's the left-hand side. Make another column. Now, I already got the not P. As long as we can read over the columns and we don't mix them up, which I have a tendency to do, you don't necessarily need to write them again, but let's put the not R here. All right. So now we are going to do the not R, which is simply the opposite of R. So it's going to be, instead of true, false, it's going to be false, true all the way down. That's just the opposite. That's all the negation is. It's just the opposite. All right. Now we're going to build this one. And we're going to use this again. And we're going to use it with that one. So it's just like regular old math. Except, you're doing it with these operations rather than add and subtracting. And these things do kind of translate in a way to math, like I said, the and the or and all that. So now, to make sure that I'm looking at the right ones, we're going to use this one and this one. And then what we're going to put here is the not P or not R. So now, oh, and this one's or now, so watch that. I would have been tempted to go and use the and again because we're creatures of habit. So this is the one we're using now. And the way that I sum it up is the disjunction is true when either one of them are true, either P or Q or both are true. It's only going to be false when both are false. So what I generally do is just look for the false ones first and then throw a T in there wherever. So we're doing this one and this one. So false is false. False, true is true. There's another false, false. False, true is true. True, false is true. We're using the or. True, true is true. As long as we got one T in there. So these are all T's, and the two falses are this one and that one. All the other ones have one T in there. The two that have no T's are that first one, which is false, false, false. It's also false. One last step. We got to put these together with an or. And this is for the whole thing, just to kind of make things a little bit short. I'm just going to put an or here. So I'm using, to remind me, I'm using the or again. So again, the or is only false when we got two F's. So we're looking at this one and this one. So false, false is false. False, true is true because this is an or. There's another false, false, so that's false. False, true is true. False, true is true. False, true is true. True, true is true. So there is what you want to use to answer your question with. That's because if they've got it is in multiple choice, then you look for the one that's the final column for. If they're just asking you to fill in, one or two rows, so you just, that's another reason why you want these to stay in the same order, those three over there, by following that pattern so that you can match them up. All right, Tori, I see you got one. Now you, does that help, or you want me to? It's biconditional.
You can go. I mean, it seems like a lot of people need a.
I'll do it. I'll do it.
Symbols. But basically, I'm just having problems with the conditional if then and then the biconditional,
Right.
and that was one of them that I kept getting wrong.
All right, let's start over. So how many? It's PQ, so it's a two statement one. So I'm going to take this one down. Okay. Oh, I was going to say that there's a little, there's an assignment in there that you could work on, but I'm thinking it's getting ready to end because I forgot to tell you about it. I wanted to have just a lot of little work in there, little bitty things, just so you can keep the best grades. I'll drop a couple of them towards the end. So if you still want to work on it, I'll extend it. I just forgot to tell you. All right, so let's do this. So this one's only going to be 4 because there's just P and Q. P, Q. All right, and then we're going to do half and half, half truths. We only got 4 this time. And then this one, like the last one on the 8 row, and we just did, it's just true, false. True, false. All right. So this is going to be the not P, because we need a not P. Oh, I should probably write that out because y'all can't see it. construct. So there we go. That's what I'm looking at. All right, so I need to have a not P right here. So that's just going to be the opposite. So instead of true, true, false, false, it's going to be false, false. Okay. Then we're going to build this whole thing. Okay. So then we're looking at this one and the Q. We don't have to worry about order here. I know that the not, P is first, but with or and the biconditional, the order is not an issue. The only one is the conditional. We'll see that in a second. Where you got to make sure you read them in order. It doesn't matter about the order though for the and, the or, and the biconditional. So it's or again. We're following this as long as we got one T. See, there's one T. So it's true. This one has got two S, so it's false. Both of these are T's. All right. Now, because order is important, I'm going to go ahead and just put the Q again, because when you're dealing with a conditional, that order is important. So I'm just going to write it again, just so I'm reading them in order and I don't have to read backwards. So Q is the true, false, true, false. So I didn't change anything. It's the same one as the Q here. I just want to put it second because now we're evaluating for that last step, the conditional. All right, so the whole thing would go up here. It's not too long, so I'll write it. So we got to get it in our head now, a different rule. The rule we're looking at now is here. This is order dependent. The only time this is ever false is when we've got order true false. All right. So we got to look for that one. Otherwise it's true. So true, true is true. False, false is true. True, true is true. And true, false, that's the bad one. That's the one that's false.
That's
So
what I
there,
messed up on. I kept on getting the true. So explain what you just said a little while ago, if that's false and that,
see this one right here?
yeah,
Order is important
okay.
for the conditional. For the other three, it doesn't matter about the order. You know,
Okay.
if it's P or Q or P. But when we're dealing with that conditional, one is the promise. The antecedent is the promise.
Okay.
So the reason why that's false is because we P there for the, and then
Wait, you break it
False.
up.
All right, so let me say this again. Is it coming in all right?
Yeah.
All right. So here's the one that we got to worry about, the one in red. Order true false, not the one that's false true, because this is the one where the promise gets broken. We've met the promise, T, and yet the result doesn't come from the intended promise. So that's why this is false. So that's the one that's last here, because you see there's true false in that order. So that one is false.
Okay, that makes sense.
So we're pretty much getting Matthew a general tour through everything when we do this. The only other thing we really, I mean, the truth tables is the central core of everything. So there's no way around using the truth tables. All right, so I was trying to read some of the comments. So, Shakina, I was trying to read what you're saying, please. Does this help? Because if you got something else, like I said, we got plenty of time. Anybody got another one? Let's see here. They really like logging me out of that. I was going to open up the book and look at a few of the things in there. But basically, truth tables is what we got to this point. Now there is like translation of the symbols, like or translates as the V thing, the disjunction, and translates as the cap, the one over the 6, which is and, of course, the and symbol. Let's see what else we can do. We got like 10 minutes. No, we still got 45 minutes. All right. We got plenty of time here. Let me look at the book. But this right here did basically what I was showing you, because all of 3.2 is just truth tables. It's got negation, disjunction, and conjunction, the conditional, biconditional, and then creating the truth tables. All right. So they've got their own summary here. It looks a little bit better than mine. Mine is kind of cut and pasted, but they got the summary here. That's the same summary that I got. Each one of these is different, so they're not interchangeable. But those are what I'm taking everything from. And they're exactly the same. See, like this right here. See, there's that one we were just talking about in the conditional, see? All of them are true. The only one that's false is order true, false. P true, Q false. In other words, antecedent is true and the consequent is false. So that's essentially a lie. That's why it's false. All right. So let's look at a little bit back in 3.1, see if everybody's got any questions over there. Because I know Matthew was asking about the symbols and stuff. And they've got the symbols here too. See, there's the or, the and, the if then.
And I think
If
it
and
helped me a
only if.
lot too with the and being like the intersection and the or being like union. That helped me.
Right. It's the same concepts. Like I said, yes. And then the reason why this fails too, if you look at it in the Venn diagram, like the um, proper subset where you got one little set fully contained within the bigger set. So if you're in the little set, you're in the bigger set. So that's what that one represents right there. Because these are not all different ideas. It's the same ideas throughout. The reason why we're going over these two topics is because in chapter 10, then you start applying them in probability. All right, let's go up and look, see what else we can get into over here in statements. So just to review, a statement has got to be, it can't be a command, it can't be a question or an exclamation. And opinions are a little bit harder to weed out, but opinions are not generally based on fact. So that's why these two things are different. You have to pass the bar exam to practice law. Now that's a true statement, but you can write it as, you can take that and write it as symbolically. Whereas with this here, chocolate cake with cream cheese icing is the best dessert ever. You would have to prove that that's true in order for it to be a factual statement. And that's one of those things you're not going to be able to do because it's like beauty or intelligence. Those things are valued differently depending on who's saying them. Yeah, Alicia, it is time consuming, believe me. All right, so here's just the compound statements. My jacket is both warm and light as a conjunction. It's a little bit clearer if you say my jacket is warm and my jacket is light, but that's what it's getting at. This is an informative website on STIs, and yesterday was the deadline to withdraw from class. So those are the two simple ones. This is a conditional statement here. This is a disjunction. So that's the gist of how these things shake out when you're talking about simple versus compound statement. A compound statement is going to have the and, the or, the if then, or the if and only if. The conjunction, the negation is the only connective where it doesn't have to connect anything. It can just work on one statement because it's the opposite. So again, negation just means the opposite. So Auburn will win Saturday. Auburn will not win on Saturday. You could also say it is not the case that Auburn will win on Saturday. You could use that same kind of thing, but the idea is that it means the opposite. So here's your symbols. This is a summary of the symbols right here. The and is the called the conjunction, and it looks like an A without the little cross piece in it. It's also, as I had said, is over in the logic section. The set theory section. We use this. Now, some textbooks actually use the same symbols throughout for logic and set theory, but this one doesn't. And then this one is that one. The biconditional is just a quality. And it has said this is the proper subset. Those all relate. back to chapter 2. So that way it'll help you remember them, because you can hopefully see that it's not so many different topics as you would think. We're just looking at and or in a little bit different light. All right. So let's just get a little bit of preview of the next hour. All right. We talked a little bit about these, like a statement can be either a self contradiction, a tautology, or neither. A tautology, this is a tautology. Okay. So if the final column is all T's, it's called a tautology. Now, we'll see later today as well in the second hour that if we have, this is an argument actually, we haven't quite learned that yet, that'll be 3.4. But if we have an argument and it's all T's, it's a valid argument if it's a tautology. If it's all F's, then that's what we call a contradiction or a self-contradiction. All right. So if it's got all F's, it's a contradiction. If it's got all T's, it just takes one F though to spoil either one of those. Because this one right here has one F. So we don't have a name for that. It's just a neither. Neither. All right. So logically equivalent statements, they'll have the same order and they'll have the exact same final truth values. In other words, if we look and compare, let's see if they got a good one in here. I thought maybe they would have this. Oh, they did it in here. All right. We're going to talk about these today too. This is the basic conditional statement. If P, then Q here. All right. There's 4 different ways we can represent those. But this one right here, if we turn around and negate, that's called the contrapositive. And the contrapositive and the initial and the original conditional statement are equivalent. And you'll see this, look. See that? True, false, true, true. And this one's the exact same order. So these things are logically equivalent. Logically equivalent, So we can use a truth table to find out whether 2 statements are equivalent. There's another way to do it with the Morgan's law, but with the Morgan's law, it's only going to, of course, going to work with certain ones because they with disjunction and conjunctions. Let's see if we can do this one. And then that way it'll give us a little extra truth table practice. So two truths, true falses. Always half and half on your first one. And since this has only got two columns, so then it's just true, false, true, false. True, false, true, false. All right, so let's see if we can do this. All right, so to do this one, we need to have the not Q. So we're doing this one right here first. So just the opposite, so it's false. True, false. All right. Now we're going to do the inside, the P and the not Q. And see, we've already got these two, so we're looking at this one and this one to get this one. And we're using the and. So one false spoils it. So true, false is false. True, true is true. False, false is false. And then false, true is also false. So this was the only one that's true, is true, true. All right, so that's the truth table for that one. All right.
What about the
Make another
not
one.
in front of it?
Well, I had done it. Yeah, I'm sorry. I'm sorry. Yeah. We got to do one more step. Thanks. So one more step. I'm rushing ahead, thinking I don't need to do that. But yeah, that's a negation. So it's just going to be the opposite of that. So it's just the opposite. So instead of false, true, false, false, it's going to be true, false. Oops. Stop. False is true, true is false, false is true. So it's, that's the one now that represents that one. All right, so we gotta have a not P to do the other two, but let's go ahead and put the not P in there. All right, so that's just the opposite of P. So it's instead of false, true, true, false, false, it's false, false, true, true. All right, now we can put that together with Q. If you need to, write it again. I'm running out of room here, but in order for the sake of clarity, I'm just going to take my Q and move it over here. Just so I got them next to one another. Because when you're reading over several different columns like that, it's real easy for me to make a mistake. So I'd like to be able to pass up tips along to you. So then it's just true, false all the way down. Okay. So now we can write here the not P or oh, it's and Q. I suspect that this one is going to be, these two are not equivalent to one another like B and C. I know enough about that to tell you that. But this one could be the same as one of these others. So we're doing and. So as long as we got one F, it's false. So false, false. There's true and there's false. Now we can use those same ones, the same two rows to do the last one. And we got just enough room to do it because it's the same thing. It's not P, but it's or Q. So now it's going to be true unless we got two falses. All right. So that's this one right here. See, false, false. As long as we got one T with an or, it's true. All right. So are any of these the same? That one is the same as this one. So A and C are equivalent. We can also use De Morgan's law to do this because the De Morgan's laws are the same as they were in chapter 2. Again, they will save you some work because if you can find out whether they're logically equivalent without having to do a truth table, then you're going to save yourself some work. So here's the De Morgan's law. Not P or Q is logically equivalent to not P and not Q. Not P and Q is logically equivalent to not P or Q. Notice that pattern. See, when we negate that, it's sort of like a negative sign in mathematics. When you distribute the things inside the parentheses, see, it passes it on to the P, it passes on to the Q, but it also changes the or into an and vice versa over here. It changes the and to an or. All right. So let's see if we can find a logically equivalent one using De Morgan's law. Well, this is not a logical equivalence. It just wants us to write the negation, but we can also use it for equivalence. I'll show you in a second. All right. So what I'm going to do is I'm going to write these symbolically. So I will study for the class or I will fail. So let's let P be study for the class. And Q is I will fail. All right. So the negation is equal to not P or Q, which is equal to not P and not Q, which is so let's write that out. Oop. Well, I hope if you can still see it. I topped it in the green, but let's see. Don't let me move it. Anyway, so I'm just going to type that out now, the negation, right there next to it. So I will not study and I will not fail. Let's do this one. We'll just do this one now because this is the or and this is the and. So again, this one is going to be I will go to the dance club. So we'll just say P, and this time it's an and then the Q is go to the restaurant. So the negation is going to be not P and Q. So by Morgan's law, that's equivalent to not P or not Q. So let's write that out. I will go to the dance. I will not go. I'm shortening a little bit just to save us some room. Or I will go to the, I will not go. So De Morgan's law can be used then to negate things. It can also be used for equivalence. Oh, and this is another equivalence. I know that they got it in there. So besides De Morgan's law, it's in my notes. We'll look at it today. But the negation of the conditional statement is this. So we got two equivalences right here. We got if P then Q is logically equivalent to not P or Q. And then if we want to negate it, it works sort of like De Morgan's law. Well, because we can change this to a disjunction, we can negate it. You can't just throw that negation in there because what do you do about the arrow? You can only negate the or the and using that De Morgan's law. So here's two equivalences. So those are two others besides the De Morgan's laws. And they check it in there and show you that they're true. So let's see. All right. So back to the conditional statement. The conditional statement, if P then Q, has four different forms. If you just turn them around, in other words, swap your antecedent and consequent or your P and Q, it's called the converse. If you keep that same order and then just negate each one, don't do anything to the arrow, but just negate P and negate Q, it's called the inverse. And then if you do both, it's called the contrapositive. So these two are equivalent, and these two are equivalent to one another. They're not all four equivalent to one another, but the conditional is equivalent to the contrapositive logically. The converse and the inverse are logically equivalent. So that means you got 8 equivalences there. You may not need all of them, but those do exist. So let's take a trip around this little thing here about writing the converse and the inverse and such. Or we'll just kind of look at it. I'll do it in the second period of it. Most probably do it there. Let's look. So write the converse, inverse, and the contrapositive of the statement. If you do well in classes, then you're intelligent. So the P, and it helps if you do define what P and Q are. So let's just say P, do well in math class. Q, you are intelligent. Okay. So the converse is just going to be turn them around. So the converse is going to be, watch it, it's going to be, if you were intelligent, you will do well in math class. See? Well, they use smart now, but it's the same thing. That's the converse. The inverse is where we just take the same order. So if you do not do well in math classes, then you are not smart. See, that's that one. Just negate them in the same order. The contrapositive is both. We turn them around, take the converse order, and then negate them. If you are not smart, then you not do well in math classes. All right, so let's look at the last thing, the arguments, real quick. So that's where we'll end at. All right, a valid argument is one in which the truth table has all T's. If it does not have all T's, if it just has one F in it, it's invalid. It's also called a fallacy. A fallacy. Fallacious argument. The truth table will always work. Sometimes there's an alternate method, as I'll show you. Let's see if they got one worked out here. Here we go. Just look at the steps on that they got. So this is an argument. All right. I'll show you a little bit more in my notes how everything translates over. But basically what you're doing is you're letting P be equal to the first simple statement. So that is the ad campaign is a success. There's only two statements in here. The other one is the marketing manager loses their job. Always write your statements when you define them like that in the positive form. So therefore, when we write this, we've got the arrow there. So if the ad campaign is a success, then the marketing manager loses their job. All right. So then the second premise is the marketing manager lost their job. So that's Q, because this was not lose their job. And here they lost their job. Shakina, what is it you're asking? I'm not sure I understand your question. All right. So then when you set that up, the line represents the cutoff for all the premises. So there's two premises here written symbolically. And then the conclusion is just what's still down there. The ... is just a shorthand for therefore. And it's the ad campaign wasn't a success, so it's not P. Well, now what we do is we're going to write it as a conditional statement. This is what they call the symbolic statement. This is the conditional statement. And an argument can always be written as a conditional statement. So premise 1 and premise 2 premises are always attached within the and. So this has got two premises, so one and separates them. After the arrow, so all of this right here, and it might be better to look like this with the brackets, how you wall it off. All that's got to be done first. And then the conclusion is after the arrow, the not P. So here's the truth table for it. So they do it a step at a time, the not P, the not Q. They do the first premise, then they attach it to the second premise of Q. Then this right here. So I would put the not P over here myself just to make it readable forward. But notice that it comes out to all T's. So all T's means that it's a valid argument. There's one more way to do it. Sometimes you can use the common argument forms. I've got them in my notes. The law of detachment or direct reasoning is one. If you've got one that's in that form, you're not going to need to worry about the truth table. The law of contraposition, that's the one with the contrapositive. There's also the law of syllogism for 3 arguments. So those are valid argument forms. If you recognize those forms, then you don't need a truth table. Disjunctive syllogism, and then common fallacies. The fallacy, the converse, and the fallacy, the inverse are the ones that are most common. All right, any questions before we Shakeen, I still not sure what you were asking there or saying, so please let me know. So that's it. If you got any questions, stick around.
I kind of get it now.
Okay. That's why I'm trying to go over, like I said, I try to use the O2O to explain things a little bit better. All right, so I'll see you in a few, about 15 or 20, okay?
Thank you.
Thank you.
All right. You okay, Matthew?